Hi everyone. This presentation is on matrix operations. First, we will talk about what a matrix is and some of its properties, and then we move on to operations. In regards to operations, we're going to learn how to add matrices, how to subtract matrices, how to multiply matrices, how also to multiply a matrix by a scalar, which is some constant number. So let's start with what a matrix is. So a matrix is a rectangular array. So I will define rectangular as 2D, two-dimensional, two-dimensional and then array. So we say matrix is a two-dimensional array. See, I think using the term two-dimensional will make more sense. So two-dimensional, which means two dimensions. If you look at this matrix here above, you got the first dimension, which is the rows, and then or the horizontal dimension if you want, and then the vertical, the columns. So the horizontal would be the rows, and then the vertical would be the columns. Maybe it would be easier to see it this way. So this is the first row. This is the second row, and this is the third row. And then in regards to columns, this would be the first column, second column, third, fourth. So two dimensions. So most of matrices are used, or matrices in general are used to store numbers. To store numbers. Each number in the matrix is called. So each number in the matrix is called an element. So an element of a matrix. For example, 8 is an element of the matrix A. -3 is an element of matrix A, and so on. Now, a matrix can be described by its dimensions. What do we mean by that? We can say, okay, I have a matrix and its dimension is 3 by 4, which is this one over here, which means 3 rows and 4 columns. That's what it means. 3 by 4 it means 3 columns and then 3 rows and by 4 columns. Okay, a matrix of m rows and n columns is said to be of order m by n. So for instance, this one is 3 by 4 because we have 3 rows, 4 columns. So the matrix above with 3 rows and 4 columns is called 3 by 4 matrix. We use an uppercase letter to label a matrix and a lowercase letter to label its elements. So we're going to talk about this now. So the notation Aij refers to the element of a matrix. The I, so you see here you got AI and then J. So I is the ith row, or the number of row, like which row it is. Is it the first row? Is it the second row? Is it the third row? And so on. And the J over here stands for the column number. So the jth row, or the jth column, the column number. So for matrix A, this matrix, if we want to know what the element A21 is, A21 it means the element uh, in the second row, first column, because 2 stands for the second row 1 stands for first column. So second row, this is the first row. Let me delete these colors. So this is the first row. This is the second row. Which one is the first column? This is the first column. So the intersection will be this one. Okay, I'm going to repeat. So second row, so this is the first one, the second row, first column. So if you cross them, if you cross these two lines, this is where they intersect. So the point of intersection will be that element. So in this case, it would be -1. A32. So that means A32 means the third row, second column. So third row, second column must be this one, -8. More examples. Um, we already talked, I think, about element -8. That's the third row, second column, so A32. And this one would be A21, second row, first column. So that's just a repetition. Example 1, it says use matrix A to answer question A, B. Use matrix A to answer question A, B. So this is matrix A. Let's answer question A. Question A says, of what order is matrix A? Well, let's count. How many rows do we have? 1, 2, 3, 4. So 4 rows. How many columns? 1, 2, 3, 4, 5, 6. Sorry. So the way we will write it is you write either 4 by 6 or 4 and you put the times. Either this notation 4 by 6 or 4 times 6. They mean the same thing. And that means the 4 rows by 6 columns. Find the following elements. That's question B. So A35. That's the third row, fifth column. So 1, 2, 3. That's so far the third row. 1, 2, 3, 4, 5. Fifth column. So that must be 5. All right, let's do this second one. A, 2, 3. Second row, third column. Second row, 1, 2, 3. Third column, 0. A4, 6. Fourth row, sixth column, 11. A12, first row, second column. First row, second column. A11, first row, first column. All right. Before we continue working with matrices, I want to give you an example um, of a matrix. Let's think of spreadsheet. And let's say in this spreadsheet, um, the spreadsheet on the on the on this column, first one, first column over here. So we hold names of students. Names of students. Let's say name. Let's just put letters A, B, C. And then on the first row over here, um, we're gonna hold, let's say the type of assessments. Okay, assessments. Let's say quiz, a test, um, project, and so on. And let's say student A got a 90 on the quiz, 95 on the test, project, let's say 89, and so on, in the numbers. Let's say 80, 75, 99, and so on. We can do more numbers. We can do 100, 80, and let's say 75. Okay, um, so this is an example of a matrix. Yeah, this is an example of a matrix. So if I want to know the one of the elements on this matrix, I can refer to it by, okay, if we're talking about student B, what did this student B get in the project? So we say, okay, it's a third, um, or if you wish, we can go with the second row, third column. So that would be 99. This is just an example of our application of matrix. You can think of Excel spreadsheet. That's actually a good example of a matrix. Matrix special names. Those are special names. Some are must know, and some are good to know, but some are must know. First one is row matrix. I think the name explains itself. A row matrix, it means is a matrix with one row. Here's an example of a row matrix. Column matrix is a matrix with one column. Here's an example. A square matrix is a matrix that has the same number of rows um, and columns. So this, for example, this matrix here, it has two rows, two columns. If it has three rows, it must have three columns. Four rows, four columns. So 4 by 4, 5 by 5, 6 by 6, 7 by 7, 8 by 8, 100 by 100, and so on. And this one actually is an important one to know. Square matrix. A zero matrix is a matrix in which every element is zero. Every element is zero. And then identity matrix, that's another important one to know. Identity matrix, it has one on the diagonal. Actually, this is supposed to be called the main diagonal. This is because this one is also diagonal, but this would be the main diagonal. So all the elements of the main diagonal are one or ones. Every element is one. And then the rest of the elements will be zero. Every other element will be zero. So the only elements that are not zero would be the elements on the main diagonal. All right. And an identity matrix, it gotta be a square matrix. Otherwise, I wouldn't work. Let's do this. 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0. You see the problem now. This is not the diagonal. This is not the main diagonal. It's you can't have diagonal on this one. So um, let's move on. All right. Matrix operations. That's what I talked about at the beginning of the lesson, which means how we add matrices and so on. So let's start with adding and subtracting matrices. To add the matrix, first of all, they have to be of the same size. Meaning, if A is 2 by 2, B has to be 2 by 2. Otherwise, we run into an issue. So let me show you how you add the matrix, and then I'll give you an example where the addition cannot be done. All right. So when you add matrix A, and when you add matrices A and B, you add the first element with the first element. So it means it's going to be A plus E, and then B plus F, and then um, C plus G. So you just add the first element to the first one, second one to second one, third one, and fourth one to the fourth one. So the fourth one, D plus H. Straightforward. If we do matrix A minus B, it's the same thing, you just subtract. So A minus E, and then B minus F, and then C minus G, and then D minus H. Now, if the matrices don't have the same size, then we can't add them. Here's an example. Let's say we got 1, 2, 3, 4. That's one matrix, and then we try to add it to this matrix. Let's do 0, -1, 3, 4, 5, 6. Now, here's the problem. You add the 1 to 0, and then you add a 2 to a -1, and then you're stuck because you want to add what to 3. You don't have an element here. It means you have to redefine this matrix. You have to make it of size 2 by 3. But if it's given to you this way, if it's given to us this way, then we cannot really change it. Then what you want to say, okay, this addition cannot be performed. Subtraction also cannot be performed. Multiplication, that's another thing. All right. Example 2. It would be a good idea actually to stop the video, work on example 2, and then you can look at the solution. Find each of the following for matrix A, B, and C. A plus B. So matrix A plus matrix B. So I'm going to rewrite the matrices. We could skip this if we want, but I'm going to rewrite it. So 8, 3, -5, 14. And the matrix B is 12, -7, 6, -23. You add them. 8 plus 12, 23 plus -7, -4, minus 5 plus 6, that's a 1, 14 minus 20, or plus minus 23. That would be negative, how much is that? 6, -9? Yeah, -9. Okay. All right, B minus C. So let's work on B minus C. Matrix B minus C. Well, it can't be done. This cannot be done. And you see that B is 12, -7, 6, -23. C is 2, 9, and we got a problem. Okay, it cannot be done. We got a problem. So 12 minus 2, and then -7 minus what? So that cannot be done. Okay, not possible. You can just say not possible. You don't have to really write whatever I did over here. All right, so this is how we add and subtract matrices. Let's look into scalar multiplication, which means multiplying a matrix by a constant number. So you can multiply any matrix by a constant called a scalar. When you do this, you multiply each individual element by the value of the scalar. That means on example 3a, you see 3 over here times this matrix. So what you do, you multiply each element of this matrix by 3. That's how you do it. So 3 times -6 is -18. 3 times -3 is -9. 3 times 7, 21. 3 times 10, 30. 3 times 2, 6. 3 times -15, -45. Good. Let's do the next one. -4 times 2, -8. -4 times -9. Negative times negative positive. 4 times 9, 36. -4 times 7, -28. -4 times 3, -12. -4 times -11. That will be 44. And then -4 times 4, -16. All right, next thing is properties of matrix operations. um, which means like things we can do or things we cannot do. For example, the addition is commutative. So, commutative property of addition. When we add matrices, whether we start with A plus B or B plus A, that wouldn't matter. That wouldn't matter. So A plus B equals B plus A. So you do A plus B or B plus A is the same thing. And then the next one will be associative property. It means if we have three matrices to add, it, whether you add the first two matrices and then you add the third one, or you you add the last two and then you add the first one to the last two, which means A plus B plus C. So you do A plus B first and then plus C, or you do B plus C and then you do A plus that resulting matrix. Doesn't matter. So it's associative. Either way, the answer will be the same. The left scalar distributive property is something we just did, scalar multiplication. So when you do scalar multiplication, you pretty much what you have to do is just distribute the scalar. So if you're multiplying a scalar by the sum of the two matrices A plus B, um, is this the same as a Ka plus Kb? Of course, I would say it's better to first add the two matrices and then multiply the resulting matrix by K. But here we're saying that, okay, this is also a possibility. We can do it this way too. In some cases, this would be easier. Now, the last thing, which would be the right scalar distributive property, um, what that means is the same as the left scalar distributive property. It's just we have a plus b then times k. Well, it's a times k plus b times k. And really, this one is the same as ka plus kb. Same thing. No difference. All right. Multi-step operations. Multi-step operations meaning more than one operation. For example, a minus b plus c, or 2a plus b. Means we'll multiply the matrix a by 2 and then add the c and so on. So that means more than one, just one operation. Example, find 4 times p plus q. So 4 times 4 times matrix p plus matrix q. So here's matrix P, here's matrix Q. This is 4 times matrix P, which is 3, 8, 3, 8, negative 2, negative 5, 5, negative 4, um, negative 4, 5, 7, 3, negative 10, um, 3, negative 10, negative 6. So it will be easier to add the matrices first and then we multiply the resulting matrix by 4. So the resulting matrix will be 3 plus minus 4, that's a negative 1. 8 plus 5, what's 8 plus 5? Is that 13? Yeah. Minus 2 plus 7, that's a 5. Negative 5 plus 3, that's a negative 2. 5 plus minus 10, that's negative 5. Negative 4 plus negative 6, that's negative 10. We're not done yet because we need to multiply 4 by every element of the resulting matrix. 4 times negative 1 is negative 4. 4 times 13 is 52. 4 times 4 times 5 is 20. 4 times negative 2, negative 8. 4 times negative 5, negative 20. 4 times negative 10, negative 40. And that's the answer. That's the final answer. And this is multi-step uh, operation. Solving matrix equation. Um, Here's an example of a matrix equation. And if the question says solve for x, you just isolate x. Same thing you do when you solve an equation for some variable. You pretty much do the same thing. But the only difference here is x is a matrix. So it means we're going to end up at the end with matrix. Because why? Because we're adding and multiplying and subtracting matrices. So when you add and subtract matrices, the resulting matrix will be a matrix. So it means when we solve for x, x is actually a matrix. But other than that, we can isolate x as if this was just some lateral equation. Let's do that. So we got 4x minus b equals a. So if I add b to both sides, a plus b. And then if I divide by 4, I would rather put 1/4 times the sum of the matrix A and B. Okay, so 1/4 matrix A plus B. We can do the addition directly without writing the matrices. So A plus B, negative 9 plus 5. What's negative 9 plus 5? Is that negative 4? Um, yeah. So 15 plus minus 7, is that 8? 4 plus 8, 12. 2 plus 14, 16. Negative 10 plus 10, that's the easiest one, 0. Negative 5 plus negative 3, negative 8. Looks good because all these numbers are divisible by 4, so we can simplify this. So 1/4 times negative 1 times negative 4. 1/4 times negative 4, that's negative 1. 1/4 times 8, that's a 2. 1/4 times 12, that's 3. 1/4 times 16, that's a 4. 1/4 times 0 is 0. 1/4 times negative 8, negative 2. And that's the matrix X will be solving for. We have come to the end of the presentation. Thank you for watching.